What if Antarctica isn't just ice, but the frozen heart of a comet that struck Earth, split continents, and reset our world 12,500 years ago?
Tonight we test a radical idea, a massive nitrogen ice comet delivered by Planet Nine's orbit, fragmented above Earth, and its core became Antarctica, the impact that ended Pangaea.
If that's true, we should find rapid continental separation, a 23.5-degree axial tilt from impact angle, nitrogen-rich atmosphere from sublimation, and synchronized geological events across the solar system.
The standard model says Pangaea drifted apart over 200 million years. But what if one catastrophic impact at 43,000 miles per hour could split the crust and push continents apart in hours, not eons?
Picture a comet, hundreds of kilometers across, approaching Earth's Roche limit at 8,000 miles altitude. Tidal forces rip it apart. The core punches through, smaller fragments scatter worldwide as the Ice Age.
The core impacts at 23.5 degrees, releasing energy beyond comprehension, billions of megatons. The crust doesn't just crack, it liquefies. A land wave, miles high, races outward at hundreds of miles per hour.
This isn't slow drift, it's instant reshaping. The Indian Plate shoves beneath the rising Himalayas. The 90 East Ridge points directly at that collision. Australia splits away. South America tears from Africa.
Antarctica, the impact core, stays locked at the South Pole. Its nitrogen ice sublimates over millennia, fundamentally altering Earth's atmosphere to 78% nitrogen. That's not volcanic outgassing, that's cometary delivery.
3 predictions. Continental geometry radiating from Antarctica, a 23.5-degree tilt matching the impact angle, and a 12,500-year timeline matching events across the entire solar system.
This explains why 90% of landmass is in the northern hemisphere. Everything was pushed away from the southern impact point. The pattern is undeniable when you look at a globe.
Planet 9, 10 times Earth's mass, 20,000-year orbit, last swept through the inner solar system circa 12,500 years ago, bringing a swarm of nitrogen ice comets from the Oort cloud.
Mars got one. The Hellas Basin, same size as Antarctica, 23,000 feet deep. Mars's axis tilted to 23.5 degrees, same as Earth. The Valles Marineris cracked open. The Tharsis volcanoes erupted opposite the impact.
Saturn lost a moon. Its rings are no older than 12,500 years. Pluto's Sputnik Planitia, that smooth nitrogen ice heart, also 12,500 years old. Triton's nitrogen geysers, same material, same timeline.
Niagara Falls formed 12,500 years ago when the escarpment lifted. Early human remains, 12,500 BC radiocarbon limit. These aren't coincidences, they're signatures of one solar system-wide event.
The evidence isn't scattered randomly. It clusters around 18 to 23.5 degree impact angles. That's the fingerprint. The angle tells you Planet 9 delivered them all at once.
If this is correct, we can predict where to look. Impact features at consistent angles, nitrogen ice deposits, sudden geological reorganization, all dating to the same narrow window.
Think about what a land wave actually means. The crust turns plastic under that energy. Rock flows like water for brief moments. Mountains rise in hours. Ocean basins form in days.
The Himalayas aren't a slow collision. They're the crumple zone where the Indian subcontinent, riding that land wave, crashed into the Asian plate and lifted 5 miles in an instant.
In China, at Zhejiang, dinosaur remains show flood burial. In Australia's outback, marine reptiles are found hundreds of miles inland. In Peru, the land of the lost reveals rapid catastrophic burial.
These aren't 65-million-year-old extinctions spread over time. They're all the same event, 12,500 years ago. Dinosaur eggs in the Gobi Desert? Roy Chapman Andrews noted they looked fresher than the expedition's own deceased pack animals. The timeline shatters. If radiocarbon dating breaks down past 12,500 years and every major geological marker clusters there, then everything we think happened over hundreds of millions of years might have happened in a day.
The impact created immediate atmospheric changes, superheated plasma clouds that incinerated organic matter, leaving footprints but no bodies, like Pompeii but planetary scale. Antarctica bears the evidence. Non-uniform ice thickness, thicker where the core was densest. The continent itself is the remnant, not a landmass that drifted, but a comet that struck and stayed.
Imagine standing on the step when the sky tears open. The ground doesn't shake. It flows. The horizon tilts. The stars shift position as Earth's axis resets. Stories become the only record that survives.
Greenland might be a secondary fragment, pushed to the opposite side by the impact's force. Its ice cap isn't ancient accumulation, it's nitrogen ice, still sublimating, still feeding our atmosphere.
The geometry is perfect. Take all ice from Antarctica and Greenland, add enough for 300-foot sea level rise, compress it to Hyperion's density, you get a sphere a few hundred kilometers across. That's your comet.
When it hit at 43,000 miles per hour, the energy released was sufficient to split Pangaea completely. Not drift. Detonation. The continents were blown apart.
Marie Tharp's ocean floor maps show the proof. Ripples radiating from Antarctica. The 90 East Ridge, a laser-straight scar pointing from Antarctic ice to the Himalayan peaks. That's your shockwave path.
Here's where we go next in this series. We'll follow those shockwave corridors, ridge lines carved by the impact, mountain belts that rose in hours, rift zones that opened overnight.
We'll compare the accepted slow drift model to the instant impact model. If continents moved in hours, we should see evidence of catastrophic velocity, and we do, in every ocean basin.
We'll examine the confounders, why mainstream science resists this timeline, what evidence supports gradualism, and where the data actually points toward catastrophism instead.
One key test. If multiple planetary bodies across the solar system show impact features at 1823.5-degree angles, all dating to the same epoch, the probability of coincidence approaches 0.
The Roche limit explains the fragmentation perfectly. Get within 8,000 miles, tidal forces overcome cohesion, and a loosely bound comet tears into a debris train. Some pieces vaporize. The core survives.
That core, nitrogen ice, rock, and iron, punches into Earth's southern hemisphere. The nitrogen sublimates over millennia, creating our breathable atmosphere. The rock becomes Antarctica's foundation.
The impact doesn't just make a crater, it pushes the entire planetary crust away from the impact point. South America narrows at the tip because that's closest to ground zero. It flares at the top because it slid farthest.
This isn't proposing instant cataclysm everywhere uniformly. It's proposing directed energy, loudest at the source, guided by crustal geometry, damping with distance but leaving clear radial patterns. Antarctica's isolation isn't from slow continental drift. It's the impact site itself, frozen where it struck. The circumpolar current, a consequence of the new axial tilt changing ocean circulation overnight.
If you're standing on Earth 12,500 years ago and Antarctica impacts, you witness axial reset, atmospheric transformation, crustal reorganization, mass extinction, and the birth of modern geography in one event.
The ice sheets grow rapidly because sublimating nitrogen ice seeds cloud formation globally. What mainstream science calls the younger Dryas cold snap is actually comet fragment sublimation triggering the ice age.
Next episode, we trace the shock through the corridors where it should scream loudest. The 90 East Ridge to Himalayas, the Atlantic mid-ocean ridge, the Andes and Rockies rising simultaneously.
This isn't fringe speculation. It's testable. Impact angles, sublimation chemistry, timing correlation across bodies, energy calculations. Every prediction can be checked against evidence.
Subscribe if this challenges how you see Earth. Tell us which continental margin or mountain belt you want examined. We'll map it against impact predictions and see what the rocks actually say.